this problem looks much more like a quadratic equation, something that you're maybe a little bit more familiar with. So what I'm going to do again is I'm going to take this guy and I'm going to rewrite it how you're used to seeing it. So you're used to seeing something like this: 2x squared minus 3x plus 1 is equal to 0. So here I've substituted, I've let sine theta be x. So now this guy, you're used to solving. Okay, so we can go ahead and factor this out. So that 0 got kind of bad because it's near the side, so let's pull it just a little bit to the left. Okay, close enough. So I'm going to have 2x and x, and I'm going to have minus 1 and minus 1. So this, if I FOIL this out, I would get back up to here. Now, just as a side note, what I've really done is I've taken the following. I said 2x squared minus 2x minus x plus 1 is equal to 0. And then I factored out, so I took the 3x, the negative 3x, and I split it into 2x and a negative x. So this is going to give me 2, if I factor here. This will give me 2x times x minus 1. If I pull a negative, I get minus on x minus 1. And then if I factor out, there's really a 1 in front of here, so I can go 2x minus 1 times x minus 1 is equal to 0. So this is factoring by grouping. So if you don't feel very comfortable with factoring, what I would do is go to a YouTube channel or go to Khan Academy or whatever it happens to be and look at how to factor by grouping. So what I'm going to do is I'm going to use this right here to factor this. So this is going to factor into 2 sine theta minus 1 times sine theta minus 1 is equal to 0. So now what you would normally do over here is you would use the zero product property. And that says that if you have two things and you multiply them together and they equal 0, that one of them has to be 0, if not both. So that means that the possible solutions here are 2x minus 1 is equal to 0, or x minus 1 is equal to 0. So that means over here our solutions are 2 sine theta minus 1 is equal to 0, or sine theta minus 1 is equal to 0. So now we have to solve it just like you would over here. So I'm going to move the 1 over. So 2 sine theta is equal to 1. So sine theta is equal to a half. And over here I get sine theta is equal to 1. So now we start grabbing angles that work on the interval 0 to 2 pi. So again, if I take a look from 0 to 2 pi, think about this in terms of your unit circle. First, sine is positive 1/2 at pi over 6 and 5 pi over 6. And those are the only two guys that fall between 0 and 2 pi. So here's pi over 6, here's 5 pi over 6. Now, when is the sine value 1? Well, that only occurs up here at the top, and that's going to be at pi over 2. So it looks like our solutions for theta are the angles pi over 6, pi over 2, and 5 pi over 6. So let's go ahead and check that. Let's go to my y equals, clear everything out, and now I'm going to type in, so I've got 2 times the sine of the angle squared minus 3 times the sine of the angle plus 1. And now I can put a 0 if I want to. Okay, I don't have to because that's the x-axis, right? Y equals 0 is the line that represents the x-axis, so I'll graph. And that's what I've got. I've got those. So the only spots where I have a height value of 0 are here, here, and here. Now those are kind of hard to see if they're the actual values that I want. So I'm going to go by pi over 6 for my steps here. Okay, so now when I graph it out, so it's here 0 to that. Don't have to go quite so high. So let's go negative 0.5 to 0.5. Let's go back to the y equals and make sure I typed everything. Oh, that's the problem. I gotta raise it to the second. It was raised to the fifth. Okay, let's go back now. Ah, there they are. So here's the pi over 6. So 2 pi over 6. So 1 pi over 6, 2 pi over 6. It looks like 3 pi over 6, which is pi over 2. 4 pi over 6, and 5 pi over 6. So these are the only values that'll work between 0 and 2 pi. They're the only ones that have a height value of 0.